In this lecture, we are going to talk about symmetric cryptosystems. In the previous lecture, we have been talking about that we have plain text and we have the ciphertext. And of course, we have to use an abstract mathematical function, the so-called encryption function, that's going to take the plain text as well as the key in order to generate the ciphertext. And of course, there is the inverse operation for decryption. It is an abstract mathematical function as well, the so-called decryption function, that takes the ciphertext and the key as the input, and of course it yields the plain text itself. We assumed that we use the same key both for encryption and for decryption. This is why these approaches are symmetric. So we use the same key both for encryption and for decryption. It may happen that we use different keys for encryption and decryption. This is what we are going to talk about in the next lecture. So we can come to the conclusion that symmetric cryptosystems use just a single key both for encryption and for decryption as well. This is why it is called private key cryptosystem or symmetric cryptosystem. Okay, so we have the plain text. We can use a key in order to generate the ciphertext, and we can use the same key in order to generate the plain text from the ciphertext. By the way, there are several disadvantages of this approach. The main problem is that this private key that we use for encryption and for decryption must be exchanged. There are several approaches. We are going to talk about Diffie-Hellman key exchange algorithm, and we will come to the conclusion that this problem can be solved, but there is another problem. If we are dealing with a large network of users, for example with cryptocurrencies, Bitcoin, Ethereum and other cryptocurrencies have a huge number of users. If we want to use encryption in order to make sure that there's secure communication between the pair of users in the network, then of course we have to make sure that every pair of users have a unique key for encryption and decryption. And we can come to the conclusion, we are going to talk about it in the coming chapters, that if we use symmetric cryptosystems, then we have to use an extremely large amount of unique private keys. That is not the best approach possible. This is why we can use different keys for encryption and for decryption, and this is how we can reduce the number of keys in the network. And this is exactly what happens with cryptocurrencies. Okay, so this is the symmetric cryptosystem or private key cryptosystem when we use the same key both for encryption and decryption. There are several disadvantages of this approach. By the way, cryptosystems such as Caesar cipher, Visioner cipher, the data encryption standard or the advanced encryption standard are symmetric cryptosystems. In the next lecture, we are going to talk about asymmetric cryptosystems. Thanks for watching.